Accessing class members. Once an object of a class is created, the object can access the members of the class. The general syntax for an object to access a data member or a method is reference variable name dot member name. The class members that the class object can access depend on where the object is created. If the object is created in the definition of a method of the class, then the object can access both the public and private members. We will elaborate on this when we write the definitions of the methods equals, makeCopy, and getCopy of the class clock. If the object is created elsewhere, for example, in a user's program, then the object can access only the public members of the class. Recall that in Java, the dot is called the member access operator. Example 8-1 illustrates how to access the members of a class. Suppose that the objects myClock and yourClock have been created as before. Consider the following statements. myClock.setTime 5 to 30. myClock.printTime open and close parentheses. yourClock.setTime x, y, z. Assume x, y, and z are variables of type int that have been initialized. If myClock that equals open and close parenthesis yourClock, these statements are legal. That is, they are syntactically correct. Note the following. In the first statement, myClock.setTime 5 to 30, the method setTime is executed. The values 5, 2, and 30 are passed as parameters to the method setTime. And the method uses these values to set the values of HR, min, and sec of the object myClock to 5, 2, and 30 respectively. Similarly, the second statement executes the method printTime and outputs the values of HR, min, and sec of the object myClock. In the third statement, the values of the variables x, y, and z are used to set the values of HR, min, and sec of the object yourClock. In the fourth statement, the method equals executes and compares the instance variables of the object myClock with the corresponding instance variables of the object yourClock. Because in the statement, the method equals is invoked by the variable myClock, it has direct access to the instance variables of the object myClock. So it needs one more object to compare, which in this case is the object yourClock. This explains why the method equals has only one parameter. The objects myClock and yourClock can access only public members of the class. The following statements are illegal because HR and min are private members of the class clock and therefore cannot be accessed by myClock and yourClock. myClock.hr equals 10. myClock.min equals yourClock.min. Built-in operations on classes. Most of Java's built-in operations do not apply to classes. You cannot perform arithmetic operations on class objects. For example, you cannot use the operator plus to add the values of two clock objects. Also, you cannot use relational operators to compare two class objects in any meaningful way. The built-in operation that is valid for classes is the dot operator. A reference variable uses the dot operator to access public members. Classes can use the dot operator to access public static members. Assignment operator and classes. A precaution. This section discusses how the assignment operator works with the reference variables and objects. Suppose that the objects my clock and your clock are shown in figure 8-4. The statement my clock equals your clock copies the value of the reference variable your clock into the reference variable my clock. After this statement executes, both your clock and my clock refer to the same object. Figure 8-5 illustrates this situation. As you can see in figure 8-5, after the statement my clock equals your clock, my clock and your clock now points to the same object. This is called the shallow copying of data. In shallow copying, two or more reference variables of the same type point to the same object. That is, two or more reference variables become aliases. Note that the object originally referred to by my clock becomes inaccessible. To copy the instance variables of the object your clock into the corresponding instance variables of the object my clock, you need to use the method makeCopy. This is accomplished by the following statement. My clock dot makeCopy open and close parenthesis your clock. After this statement executes, the value of your clock.hr is copied into my clock.hr. The value of your clock.min is copied into my clock.min. The value of your clock.sec is copied into my clock.sec. In other words, the values of the three instance variables of the object your clock are copied into the corresponding instance variables of the object my clock, as shown in figure 8-8, 8-6. Objects my clock and your clock after the statement my clock that makeCopy open and close parenthesis your clock executes. This is called the deep copying of data. In deep copying, each reference variable refers to its own object, as in figure 8-6, not the same object, as in figure 8-5. Another way to avoid the shallow copying of data is to have the object being copied create a copy of itself and then return a reference to the copy. This is accomplished by the method getCopy. Consider the following statement. My clock equals your clock dot getCopy. In this statement, the expression your clock dot getCopy makes a copy of the object your clock and returns the address, that is the reference, of the copy. The assignment statement stores this address into my clock. Note, the methods makeCopy and getCopy are both used to avoid the shallow copying of data. The main difference between these two methods is to use the method makeCopy, both objects, the object whose data is being copied and the object that is copying the data, must be instantiated before invoking this method. To use the method getCopy, the object whose data is being copied must be instantiated before invoking this method, while the object of the reference variable receiving a copy of the data need not be instantiated. Note that makeCopy and getCopy are user-defined methods. It is important to understand the difference between the shallow and deep copying of data and when to use which. Shallow copying can produce unintended results, especially by beginning Java programmers.